Hello guys, welcome to lesson 822 day 1. Today's focus was just doing more operations with complex numbers. Last week we talked about what complex numbers are, where they come in, how to find complex roots and stuff, and so now we're just going to talk about operations within complex roots and numbers. So we'll start with adding and subtracting. When we are adding and subtracting complex numbers, there are a couple things that we need to just pay attention to in particular. The first thing that's really important to remember is that if there is subtraction going on, we've got to distribute the negative sign. So, gotta distribute the negative sign when it's subtraction. Alright, the other important one, excuse my hideous handwriting. The other part is that we are going to have to combine like terms. And that's something that you guys are used to doing at least. So, for example, let's just do a basic one. If I was adding complex number 2 plus I, actually let's do subtraction. 2 plus I minus 3 plus 2I. Okay, so let's just go ahead and follow the process here. The first thing you want to do is to subtract this negative sign, distribute this negative sign so that everything is out of the parentheses and we can just work with all of the like terms at that point. So we have 2 plus I minus 3 because it's a positive 3 and we're distributing in a negative 1. And then here, this positive 2I will also turn into a negative. Okay, now I can go ahead and combine my like terms. So I know that 2 and negative 3 are like terms because they're both just plain old numbers. And then I and negative 2I are going to be like terms as well because those are both I terms. Remember, we cannot combine regular numbers with I terms. So let's go ahead and combine those and see what happens. 2 and negative 3. Well, 2 minus 3 is going to simplify to negative 1, and the positive 1I minus 2I is actually also going to be a negative 1. Basically, it's going to be a negative 1I. If you just wrote minus I, that's the same thing. Remember, if it's a 1, it's typically optional. Alright, so our final answer is negative 1 minus 1I. So that's an example of subtracting complex numbers. Adding complex numbers would go the same way, but there just wouldn't have been a subtraction sign and a negative sign to distribute. So the next example we'll do is multiplication. So let's go ahead and multiply some complex numbers. We'll use the same numbers for our example, but this time, of course, instead of subtracting them, we will go ahead and add them. Some important things to keep in mind for multiplication is that we need to use the box. We've used the box many times before, so hopefully it's very familiar. And the other portion of that is that we have to make sure we simplify powers of I. Typically we'll just be working with I squareds for the most part here, but I'll mention it, you never know. Sometimes you can have larger powers. So for our example, we'll say we will do 2 plus I times 3 plus 2I. Again, I used the same numbers as the last example, but just got rid of that subtraction sign. So now we can go ahead and make our box. Like I said, this should be a step that's pretty familiar to you guys, because we did this like a million times last semester. So we have 2 plus I on the top, 3 plus 2I on the side. Of course, as you guys know, it doesn't matter which one you put on the top and which one you put on the side. So we'll do the multiplication and fill in the boxes. 3 times 2 is going to be 6. 3 times I is going to be 3I. 2 times 2I is 4I. And 2I times I is 2I squared. Alright, so now we can go ahead and write out all of these terms in here and add them together. So 6 plus 3I plus 4I plus 2I squared. At this point, we're ready to start combining like terms, simplifying whatever we can. So this 3I and 4I will combine to make a 7I. And the 2I squared, hopefully you guys remember that I squared is also equal to negative 1. In case you forget, Remember, we have I is equal to the square root of -1. So I squared would mean to square that. And squaring a square root is going to result in just whatever was inside. All right, so now we can just go ahead and simplify whatever's left. So we can rewrite this as 6 plus 7i minus 2, because 2 times 1 makes this a -2. And of course we can combine the 6 and the -2. So this gives us a final answer of 4 plus 7i. And we're done. For a little more practice here, let's do another addition and subtraction. So if we were adding these, because there's no negative to distribute, we can pretty much just ignore the parentheses there. And we can go ahead and combine like terms. So 3 and 5 are like terms. I and 2i are like terms. So we end up with 8 plus 3i. All right, for this one we have subtraction, so this time we have to pay attention to that negative sign. So minus 5 and minus 2i. Remember, those signs have to change. So we end up with 3 minus 5, which is -2, and this is an I. 1 minus 2i is going to be -1i, so minus 1i. And that's my final answer. All right, so next we're going to talk about a vocabulary word here called the conjugate. It's a really ugly line, but it's fine. And what a conjugate is when the terms inside these parentheses are pretty much the same, but the one difference is that one of them is a plus, one of them is a minus. So here I have 2 plus I versus 2 minus I. Another really random example would be like 3 plus 4i and 3 minus 4i. Okay, so any situation where these two parts are the same, but the sign just changes between positive or negative or plus or minus. So here, let's see what happens when we add two conjugates together. We have 2 plus I plus 2 minus I. We can get rid of the parentheses because we don't have any negative signs there, or we don't have a minus sign. So 2 plus 2 combines to make 4, and hopefully you'll notice that this positive I and negative I actually cancel out. So we are ending up with a final answer of 4. So the I terms all went away. And it makes sense for them to go away because if the terms themselves are the same but just the sign changed, of course there will be a positive and a negative to just cancel each other out. So we see that when we add conjugates, we end up with no I term. So let's see what happens when we multiply conjugates. We've got 2 plus I and 2 minus I. So multiply them out. 2 times 2 is 4, 2 times I is 2i, 2 times negative I is negative 2i, and negative I times I is negative I squared. Be very careful with your signs on these i's. So let's list them out. We've got 4 plus 2i minus 2i minus I squared. So right away we should notice that 2i minus 2i will cancel out. So we end up with 4 minus I squared. I don't want to see any I squareds in your answers. You have to simplify those. We know that I squared is equal to -1, so you've got to replace I squared with -1 every time you see it. So 4 minus -1, that's the same as 4 plus 1, which is 5. So just like when we added the conjugates, when we multiply them, we also get rid of all of our I terms. So it kind of makes your life a little bit easier. You have less to keep track of in that case. And then sometimes you can also find some shortcuts. Like here, it was pretty clear that we would end up with just the first terms multiplied by each other. All right. There's one last thing you have to be able to do for this set of open math problems, and that is to write the equation given roots. We have already done that with regular roots, and so we're really just going to use that to introduce doing it with complex roots. So over here, if I told you we have roots of 2 and 6, you want to start by writing out your factored form equation. And that means we just need the parentheses. And if your root is positive 2, we put a minus 2. If your root is positive 6, we put a minus 6. You always take the opposite sign. And that's all you have to do for factored form. Because factored form just means you want all those parentheses. Standard form, however, requires us to multiply all of this out. And this is the format in your Open Math problems. I've had a lot of people ask me questions about why they got it wrong on Open Math. And a lot of you guys put this parenthesis form. We want it in standard form most of the time. So let's go ahead and make our box, and we just want to multiply those pieces out. So x minus 2, x minus 6. My personal preference is to put the negative like right next to the number if I'm writing it on the side, because otherwise you might forget it's there. So x times x is x squared, x times negative 2 is negative 2x, negative 6 times x is negative 6x, and negative 6 times negative 2 is 12. So now to simplify, we'll write out everything first, combine afterwards. So this is everything that was in my box, and I can combine my negative 2x and negative 6x. So that's going to leave me with a final standard form simplified answer of x squared minus 8x plus 12. All right. So just like we did this with regular roots, we can do this with complex roots as well, and the process really is the same. It's just that now you're involving some i's. So if I told you to come up with a factored form polynomial that has roots of 2i and negative 2i, you'll start the same way. Make your factors. If I have a positive 2i, I should put negative or minus in my parentheses. Negative 2i ends up with a plus 2i in my factor. And that's it for factored form. Factored form is certainly the easier one of the two. So now let's go ahead and multiply those out to figure out the standard form version. Again, that's the one that Open Math is asking for. Alright, we have x minus 2i, x plus 2i. Also, something worth noticing is that these are conjugates, so you shouldn't end up with any I terms in their final answer. X times x is x squared, x times negative 2i is negative 2ix, kind of a weird term, but that's okay. 2i times x is 2ix, and 2i times negative 2i is negative 4i squared. Alright, so when we put those all in a line, we have x squared minus 2ix plus 2ix minus 4i squared. So here begins the simplifying. The 2ix terms cancel out. We end up with x squared minus 4i squared. And again, remember what I said about I squared terms. These always have to be replaced with a negative 1. So x squared minus 4 times negative 1. And this I squared turned into a negative 1. So negative 4 times negative 1 is actually a positive 4. So your final answer should be x squared plus 4. And that is your standard form. So give those Open Math problems a try if you haven't already, and let me know if you have any questions.